Welcome to Royal Math Podcast. Today we'll be looking at Activity 8, Ratios and Proportions. So before we take a look at the lesson, let's go ahead and take a look at some of the key words that are in this activity. First off, we have ratio, which shows the relative sizes of two or more values. Ratios compare like objects, and ratios can be displayed in three different ways. So when I said they compare like objects, I mean things that are of the same nature. So I could compare the number of tiles in my classroom to the number of tiles in the hallway. Or I could compare male students to female students and other demographics that are of the same nature. So they can be written in three different ways. So if I go back to one of the original ratios I just talked about, boys compared to girls, I could say there are 8 boys to every 3 girls. So 8 to 3 is the ratio of boys to girls. I could also write it as 8:3, and I could write it as a fraction 8/3. Now rate is a ratio that compares two different units, such as distance and time is one of the most commonly used ones. So I could say I drove for 500 miles, and that took me 10 hours. So when I write that rate, 500:10, 500 to 10, or 500/10. Now a unit rate is a rate expressed in terms of 1. So that means one of the two numbers, or three numbers, will be as a unit of 1. So using the same example for rate, 500 miles in 10 hours, I could simply state that I do 50 miles per hour, or 50 to 1. Because when I take my original ratio, 500 to 10, and I divide both sides by 10, I get a unit rate over here of 1, and then 500 has 10 go into it 50 times, so 50 to 1. Now let's take a look at some problems. All right, so here we have a word problem that says in 2002, Takura Kobayashi ate 50 hot dogs in 12 minutes. At that rate, and assuming that he wouldn't explode, how many dogs could Takura eat in an hour? Well, the first thing we have to do whenever we work out a proportion is we draw our three fractional lines. So I'm going to draw 3 lines going across here. Now, we have different things that go in the different areas of our 3 fractional lines. First off, right here, we have our definitions. And our definitions basically tell us what goes on top and what unit goes on bottom. Our next line that we have is our what we know column. And what we put there is information that we got from the problem itself. And finally, last but not least, we have our solve column. And this is the information for what we're trying to figure out, what we're solving for. So now, let's go ahead and take a look at the problem in general. So in 2002, Takura Kobayashi ate 50 hot dogs in 12 minutes. So we have to define what information we're putting on top and what information we're going to put on bottom. Now, as you can see here, they gave us 2 different types of information. They gave us how many hot dogs he ate, and they gave us how long it took for him to eat it. But that's not always exactly what we're going to do our definitions as. We can also find what we're going to define the fractional lines as in what they're actually asking. And here they ask, how many dogs could Takura eat? How many dogs could he eat in an hour? So we're still dealing with hot dogs and time frame, but now we are given a specific rate. Okay, so now let's go ahead and fill in our definitions. So I'm going to put hot dogs on top, and I'm going to put time in minutes on bottom. Now, I know I underline in an hour, but the good thing about an hour is it can also be represented in minutes. Therefore, there's less conversion we have to do. So let's fill in the information we know. We are given 50 hot dogs in 12 minutes. So hot dogs is listed on top. So we're going to write 50 on the top of the fractional line for what we know, and then 12 minutes on the bottom of that fractional line, because that's where our definition tells us it should be. So now we go over to the solve rate. It wants to know how many dogs could Takura eat in an hour. So I'm going to place that time frame of an hour, which, because we have 12 minutes, we're going to write this as 60 minutes, which does equal an hour, but it keeps the same time frame units as what we have in minutes. That's important. We can't mix minutes and hours or feet and inches. Whatever unit of rate we have has to be consistent across the fractional lines. So, and of course, we want to find out how many dogs, so we will put our variable up on top. So now all we have to do is cross multiply, and this proportion will give us an equation for fruition. So 12 times x is 12x. And what does that equal? That equals 50 times 60. So we come over and we do 50 times 60. Of course, one way to speed this up is simply to do 5 times 6, which is 30. And then we add the 2 zeros back in. So 50 times 60 is actually 3,000. So 12x equals 3,000. Now we're going to follow our basic rules of solving equations. We don't have a constant, so we can skip that first step of inverse operations of the constant and skip right to inverse operations of the coefficient. Our coefficient is 12, and it is multiplying x, so I'm going to divide both sides by 12. When I do this, I'm left with only x on the left side of the equal sign, and over to the right side, I need to take 3,000, put it inside the house, and divide it by 12. So 30 divided by 12 goes into 2 times, that's 24. With 6 remainder, bring down our 0, and we know that 12 will go into 60 5 times. And then we bring down our last 0. How many times will 12 go into 0? It will go 0 times, so we're left with x equals 250. And that stands for hot dogs. So if he ate at the same rate without exploding, he would end up eating 250 hot dogs in 1 minute. Now let's take a look at a word problem proportion that's a little bit different. So this one says a cross-country team has a boy-to-girl ratio of 3 to 5. If they have 40 members on the team, what is the amount of boys and girls on the team? So to do this, of course, we're going to write a proportion, which means we always start with our 3 fractional lines. So let's go through here and look at the information they've given us. They give us the amount of boys, they give us the amount of girls, and they tell us that they have a boy-to-girl ratio of 3 to 5. So that means every time there's 3 boys, there's going to be 5 girls. And if they have 40 members on the team, what is the amount of boys and girls on the team? So as we're solving this and we're trying to figure out the total amount of boys and girls, we're looking at one thing. We need to have one item on top to define and one item on the bottom. Well, basically, we're looking for the amount of gender, the amount of boys, or the amount of girls that we have. So we can only figure out one of those at a time. So let's just go ahead and start with the number that's first, which in this case would be the amount of boys. Okay, now what are we looking for? We're looking for the amount of boys or girls in a group of members, of 40 members to be exact. So on the bottom, we're going to put members. So now let's go back and let's figure out exactly what to put. I think it's obvious what to put for the amount of boys, because we see right here, boys is listed first and 3 is listed first, so we know we have 3 boys. But what to put on the bottom? Because it says members, and the only number that we've been given for members is 40 members. But that 40 members is the total amount. And we want to figure out when it says 3 to 5 ratio. So let's take a look at this with tally marks and see exactly what it means. It means whenever we have 3 boys, we're going to have 5 girls. So let's count this up. We have 1, 2, 3, 4, 5, 6, 7, 8. So altogether in this unit right here, at this group, we have 8 members. So we are going to put 8 members on the bottom. Now, let's take a look at the other side. Once again, we saw that we're asking if they have 40 members on the team, what is the amount of boys and girls on the team? So we're going to put 40 for the members here, and of course, we don't know how many boys or girls we have for that scenario, so we're going to go ahead and label it as such, X, to find out what we're looking for. So now, once again, all we do is cross multiply. So 8 times X is 8X, and that's going to equal 3 times 40, which is 120. So now what we do is we get to skip the step of inverse of constant because there is no constant here, and we go straight to inverse of coefficient. So when we divide both sides by the coefficient, which is 8, we get X remaining on this side, and then we have to find out how many times 8 will go into 120. And so what we do is we set this up, we multiply, and we can see that 8 goes into 120 15 times. So X equals 15. So that means we have, X is representing the boys, we have 15 boys. So I'm going to write right here, boys, 15. Now the problem said to also find out how many girls. So we could input a 5 in place of the 3 and work this entire proportion over again, or we could simply know that there are 40 members and 15 of them are boys, so when we subtract that, we are left with 25, which is the amount of girls on the team. Thank you for paying attention to Royal Math Podcast. Have a good day. See you around like a donut.